Alright, this video is going to be on differentiation rules. So these are going to be the shortcuts we can use to find the derivative so that we don't have to use limits every single time we want to find the derivative. So we're going to go ahead and write this in our notes. All of these rules can be proved using the limit definition of the derivative. So what I mean by that is this process that we've been doing where we say the limit as h approaches 0 of f of x plus h minus f of x divided by h. So that, if you guys recall, that definition of the derivative comes from finding the slope between 2 points and saying that the distance between those 2 points is approaching 0, and so that's how we're finding that instantaneous rate of change. So we've been doing this process every time, and now we're going to say we can use these shortcuts, and the one exception to using these shortcuts is when they ask us specifically to use the limit definition of the derivative. So if they ask us to use it, then we have to, but the rest of the time we'll be using the shortcuts. So we're going to say no more limit definition of the derivative, so we don't have to use that process unless we are asked to do so. Alright, so we are going to go ahead and move on to some formulas for us to find these derivatives as like shortcuts. So the first one is for constant functions. And as you guys know, a constant function is where we can say that the function is f of x equals some constant, or it just equals some number. And so the derivative of that, f prime of x, the derivative of a number is just 0. So, for example, if we have y equals 3 as our horizontal line, then we know at any point on that horizontal line that instantaneous rate of change, or that slope at any point on that horizontal line, is going to be 0. So we say y prime equals 0. The derivative of 3 is 0. Alright, so those are obviously pretty easy. Let's go ahead and do another one. So this one is going to be the power rule. I'm going to keep that color. So if our original function says f of x equals x to the n power, so x to some number, then we're going to say that the derivative of that is n times x to the n minus 1. So what we did is we took that exponent, we moved it to the front, and then the exponent dropped by 1. This is the rule that in 10 years, when you remembered nothing else about calculus, this is the rule that you're going to remember. So for example, if we have the function f of x equals x to the third, then the derivative of that, we're going to take that exponent of 3 and move it to the front, and then we're going to take that exponent of 3 and drop it by 1, 3x squared. Alright, the next rule is the constant multiple rule. And the constant multiple rule says that if we are taking a function and it has some sort of constant in front of it, and I want to figure out what the derivative of that is, then it's just going to be the constant times the derivative of the function, which is definitely easier than it sounds. So for us, let's go ahead and do an example. We're going to say that our original function is y equals 4x to the 8th power. And we're going to think of this, now I'm using my formula here, I'm going to keep that constant in the front, so constant multiple in the front, that coefficient, and then I'm going to take the derivative of x to the 8th. So the 8 drops to the front, so that's 8x to the 7th. And then I'm going to go ahead and simplify that problem by saying that the derivative is 8 times 4, which is 32x to the 7th. Now, most people, I would say, would not do that in 2 steps. They would just go and look at this original problem and say 8 multiplied by 4 is 32, and write the 32, and then put the x to the 7th. So you can do it in 2 steps when you're beginning with it if you want, but you don't have to. You can do it all at once. All right, the next rule that we're going to look at is the sum and difference rule. And the sum and difference rule says that if you're taking one function and adding it or subtracting it to another function, and you want to take the derivative of that, then that's just going to give you the derivative of the first function plus or minus the derivative of the second function. So it just means that you can take derivatives of 2 different pieces separately and just keep the plus sign in between them. So we're going to go ahead and look at an example of this. If we have f of x equals 7x squared plus 3x to the 3rd minus 4. Now you could think of that as one polynomial function described as f of x, or you could think of it as this is like g of x, h of x, j of x, like 3 different functions that are being added or subtracted together. So what that rule is saying is just take the individual pieces and do the derivative of each one separately. So the derivative of 7x squared, the 2 would multiply by the 7 to give us 14, and then we would drop the exponent by 1, so 2 drops to a 1. 3 times 3 is 9, x to the 3 drops by 1 to the 2. And then the minus 4 on the end, we have minus 0 because 4 is a constant. Technically, we don't even have to write that. All right, so here we're going to say our final answer is 14x plus 9x squared. You could switch the order of that so that it's more proper if you would like. Okay, so those are all like the easy rules. I think most people kind of think of all 4 of those rules as just one rule, and they think of it kind of as like the power rule, just that idea of taking the exponent, dropping it to the front, that sort of thing. But these other 2 rules you will remember as 2 distinct different rules because they are important little tricks to remember. So the next rule is the product rule. And the product rule says that if we have one function being multiplied by another function, and we want to find the derivative of those, then the derivative is the first times the derivative of the second plus the second times the derivative of the first. So again, and you might write those words out, the first times the derivative of the second plus the second times the derivative of the first. And I'm going to phrase it like that all year because that's how I learned it. So the first times the derivative of the second plus the second times the derivative of the first. So here we're going to say that the problem that we're doing is x to the 6th minus 1/8 x to the 4th times x plus 2. Now you have two options with this if you wanted to find the derivative of f of x. If you wanted to avoid using the product rule, you could just FOIL that out and figure out what it is, and then you could take the derivative of each piece separately. And then you'd be fine, you get the right answer. Or you could look at that and say, I've got one set of parentheses and another set of parentheses, they're being multiplied together, so the product rule applies. So there are two different ways to do this problem. We're going to use the product rule because that's what we're on. So we're going to say the first times the derivative of the second, so I'm going to keep the first set of parentheses the same. In the derivative of the second, we've got the derivative of x. If you think about that x, it's got an exponent of 1. So if you drop that 1 to the front, then that would make it 1x to the 0, if that makes sense. So 1x to the 0, anything to the 0 power is just 1. And so 1x to the 0 is actually just 1. And then the derivative of 2 is just 0. So we've got the first times the derivative of the second, plus the second times the derivative of the first. And the derivative of the first one would be 6x to the 5th minus 4 times 1/8 would be 4/8 x to the 3rd. All right. And then at this point, we just need to simplify our answer. And I didn't write any notation there. You can go ahead over here and we can say f of x equals that. Okay, so we have, well, f prime of x. F prime of x equals, this stuff multiplied by 1 is just going to stay. And then over there we're going to have to FOIL. So I've got x times 6x to the 5th is going to be 6x to the 6th. I have x times negative 1/2 x to the 3rd. That's going to be negative 1/2 x to the 4th. Then I have 2 times 6x to the 5th, so that is 12x to the 5th. And then I have 2 times negative 1/2 x to the 3rd, so that is negative x to the 3rd. And then I can go ahead and combine my like terms to see what my final answer is. So it looks like my highest exponent of x is a 6. So I've got 1 there and 6 there. That makes 7x to the 6th. And then I've only got one term that's to the 5th. I've got negative 1/8 x to the 4th and negative 1/2. That's negative 4/8. So altogether that's negative 5/8 x to the 4th. And then minus x to the 3rd. Alright, so that's the product rule. Basically, you just have to remember the first times the derivative of the second plus the second times the derivative of the first. Alright, the sixth rule. The sixth rule is called the quotient rule. And the quotient rule is if you're taking one function and you are dividing it by another function, and you want to take the derivative of that, then the quotient is the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. So a lot of people, well, I don't know, a lot of people might be an over-exaggeration. I learned it in high school as low d high minus high d low. So let me circle this as I go through it. So this is low times the derivative of high, so low d high minus high, the top, times the derivative of the bottom. Low d high minus high d low. So I'm probably going to say that a lot because that's how I learned it. And then divided by the bottom squared. I don't know how to remember that part. So we're going to go ahead and do an example of that one. So our example here is y equals x plus 2 over x plus 3. Most people don't like the quotient rule. For the most part, we're all going to avoid it as much as we can. However, in this case, you cannot possibly avoid it. You have to do it. So that's a lie. You could do the product rule, but we're not. We're not going to break it up. We're going to leave it like that. We're going to go ahead and do the quotient rule. So low d high minus high d low divided by the bottom squared. So we're going to say y prime equals low times the derivative of the top, and the derivative of x we just said was 1, plus derivative of 2 is 0, minus the top, so high, d low, so times the derivative of the bottom. The derivative of x is 1, the derivative of 3 is 0, divided by the bottom squared. Alright, so on the top, we have x plus 3 times 1, which is just x plus 3, and then we're subtracting x plus 2 times 1, so we're subtracting off x and we're subtracting off plus 2. And we've got x plus 3 squared. So the x's cancel, and we get that the derivative is 3 minus 2, which is 1, over x plus 3 squared.